we are discussing about experimental method, and for conducting experimental method we must understand first why we are doing so. When we conduct experiment on the small population, it is called a sample. On that sample, and then we want to generalize. What is the meaning of generalizability? When we conduct some experiment on small sample, we are saying the results are applicable to population. Results are applicable to the whole population. So in order to do that with confidence, we must also understand how we must conduct the experiment. And for that, we must be aware about the threats to internal validity and to external validity. So we will see some of the threats today, and then we will see how to conduct various experiments using different designs. There are many different threats to internal validity. Some of them are here: history, maturation, testing, instrumentation. What is history? It is unanticipated events occurring while experiment is on. So something happens, and then it happens for one group, it doesn't happen for another group, and then even if you go ahead with the experiment, then the results which you got, the findings which you had, will not be really generalizable. So either it will affect experimental group or control group, that means dependent variable itself is affected. Threat means negative impact or negative effect on our dependent variable. Maturation. What happens? You are conducting the experiment over a period of time, say 1 year or 1.5 years. So what happens? Those students who were 10-year-old now will become 12-year-old, or 11-year-old will become 13, and they will enter into the teenage. So they are matured. So what you started with, and now this maturation, age maturation effect will really impact your dependent variable. So while conducting the experiment, time frame is also very important. Sometimes it also happens you are conducting first on control group and later on experimental group. Suppose you don't have other infrastructure facilities, you don't have time, you don't get another teacher, then the same teacher conducts experiments for both. Then what happens? This is conducted for 6 months and another is conducted for next 6 months. So that age maturation of any group, experimental or control, will definitely affect the dependent variable. So you have to be extra careful about it. Testing. The effect of taking one test upon the scores of a subsequent test. So sometimes even if you give a pre-test, people get test wiseness. So now you know how to write the test. With your scores, you might get higher scores. So generally, best experiments are, suppose you don't give the pre-test, you give only post-test. Only one test. So one test should not have effect on others. Instrumentation. If your measuring instrument is not correct, what is measuring instrument now? In case of say achievement, it will be your achievement test. In terms of attitude, it will be your attitude scale. So these are all instruments which we use. So if they are faulty, if they are not allowing you to interpret properly, then your results will be affected. Dependent variable observations will be affected. Naturally, your validity is at risk. Statistical regression. Differential selection of subjects, experimental mortality, selection, maturation, interaction. What is statistical regression? Have you heard this word regression? To regress, to come down. So regression means if you take a statistical average, then there is a tendency that scores come down or come up to averages. So that's why if you have extreme scores, you have already studied statistics. So there is a tendency of extreme scores towards going towards averages. In the pre-test, if you have range from 6 to 60, and then if you conduct an experiment, you will find that 6 and 60 are gone now. They will all converge down to 40, 45, 50. So this tendency is always there. So you might feel, I have done a good job. My experiment was good, that's why they got the mark. It's not because of that. This is called statistical regression. So you have to be careful with it. So what statistics we must use, that also will be your responsibility. Differential selection of subjects. If subjects are not randomly selected, randomly, I am using the word random, means every subject had equal opportunity of being selected. So now there are 1200 schools in Mumbai. If you select a school which is next to your house, that means your selection itself is wrong. That school may be having all very good students and you are going to conduct an experiment there, then you will definitely get good results. So how to select that one school? So you must have studied that in sampling. Various technique sampling procedure is there. Stratified random sample. You have to use certain aspects, certain criteria for selecting. So if we don't select that school itself, and within that school again we have to select the subjects. So how have that bias at the back of your mind every time? Then your whole experiment gets affected and naturally your internal validity is at stake. Groups are not equivalent to start in the beginning. One group is here and another group is here, and you are giving them treatment and you are saying this group went up naturally because it was already there. So both the groups should be on the same wavelength, and then you see with your treatment what happened. Experimental mortality. You know the meaning of mortality, so don't take it literally here. Nobody is dying. Mortality, experimental mortality means you have started the experiment with 40 students and day by day they got bored. They left your experiment. The control group from 40, the number came down to 25 and experiment. Now can you compare both the groups? Or even the other way around. Experimental group went down and control group is there. So this mortality, we call it mortality. The students have now left. No, they are not for your experiment. So that is experimental mortality. So that will affect your score. Because when you use the statistics, you also must be knowing less than 30 is called a small group. Above 30 is called a large group. Differential loss of subjects. So who is dropping? You don't have any control on that. One student having 60 marks is dropped from here and another student having 40 marks is dropped from here. You had equated them in the beginning, but who dropped, you don't have control. So what you get, the output may be affecting your observation. Selection, maturation, interaction. Now we are talking about two variables affecting each other. Maturation not being consistent across the groups because of some selection factor. If you have selected them on their achievement score or the variable which you want to test. So you selected them on attitude about say film, but their age you have not seen. Their scholastic achievement, they selected them on one particular variable, whereas what is happening? Maturation because of age may be different. So though you are concentrating on attitude, 2 students in your class are 16 years and 3 students there are below 16 in control group, then naturally their maturation will have impact on your. So see now, do you see that how many variables you really have to study before you make any choice of subjects? You select subjects. These were threats to your internal validity because then your observation itself is wrong. Now we will see external validity. External validity is for generalizability. You want to generalize, and if you are not able to generalize, then your experiment is wrong. Nobody would believe your findings. Threats to external validity. Interaction effect of testing. interaction effects of selection biases and the experimental treatment, reactive effects of experimental arrangements, and multiple treatment interface. We have already said that if you give a test, the test wiseness comes there. But here we are saying interaction effect of testing. Pre-testing interacts with the experimental treatment. How? For example, you have given them a test of viewing a television test, and then your experiment is also on viewing the television. So what happens? Your test has an impact on, because you have already given them feedback. So now they know how to appreciate the film, how to see the film. So as it is, both the groups have that impact. So this interaction among pre-testing and experimental treatment has to be looked after. Another thing is, you will see that it will affect the scores, but you may not be able to generalize. What is that generalization? You will say that this particular treatment enhances students' appreciation of film. Okay, that comes the result. But you never say whether that pre-testing was given. You are only making a finding. So generalizability is only in case of pre-testing. So if you give a pre-test, then only this treatment enhances the film appreciation. So your generalizability is reduced immediately, because 100% were there. Suppose only 30% are given pre-test, then generalizability is reduced. Not everyone would like to give pre-test. So generalizability means the application of your findings to the whole population. That's what we are talking about.